The SAT has been testing these kind of exponential story questions more and more recently. Maybe it's just a coincidence, but I do think they're coming up more often, and a lot of people have trouble with them. I will tell you the stuff you need to kind of memorize to get this right, and to make it easier to get right, I should say. But I don't think that not memorizing it is an excuse, right? So if you saw this on a test and you notice like, oh, I don't really remember how these work, or I'm not familiar with these types of equations, honestly, like you've got to change your strategy and the way you think about things. That's not an excuse. You can get this right if you're clever, because we're being asked what's happening over time with this equation, right? What happens well, I guess not all the choices. Choice A is not really over time, but a lot of these choices are testable. So let's look at A. That's the easiest one, right? The model predicts that there were approximately 1.11 flower beetles in this area on June 1st. And June 1st is the baseline for the equation, where T represents the number of days after June 1st. So June 1st is how many days after June 1st? 0. So arithmetize here. This choice A is giving you an arithmetize situation, right? So just do what it says. If they're telling us that what's going on June 1st on the t equals 0 point, then we can figure that out just by plugging that into the equation. So b of 0 is supposed to be 100 times 1.11 to the 0. Here's where you have to memorize something. Anything raised to the 0 power is 1. So this is really just 100 times 1, which is 100. So are there 1.1 flower beetles in this area on June 1st? No. There are 100 flower beetles. There you go, proven wrong. So you don't need to know anything about like why this equation is structured this way in order to prove this choice wrong. We're going to see that that's going to continue here. Look at choice B. The model predicts that the number of flower beetles in this area increases by approximately 1.11 each day. Well, we know what happens on day 0. We know that we start with 100 of these beetles. If it's supposed to increase by 1.11 each day, then let's see what happens on the next day. Let's just see what happens when 1 day has passed, when t is equal to 1. I know this is no calculator section, but you should be able to see that this is not going to work, right? So b of 1 is now 100 times 1.11 to the first. Anything to the first is just that number, so this is also easy to do, especially because it's 100. So 100 times 1.11 is 111. So did it increase by 1.11 in a day? No, it increased by 11, right? By 11 beetles. So again, I don't understand necessarily what the structure of this equation is saying, but I just used real numbers to prove the math of these answer choices wrong. This is arithmetizing at its best. It's not just telling us what's happening at one point, but we can arithmetize to see multiple points, to see a change and see what happens. So we just proved this wrong. Let's keep going. The model predicts that it will take approximately 1.11 days for the number of flower beetles to double. So here's a case where we don't even need to do the math. We can kind of just see like, all right, well, we saw what happens after 1 day, right? 1 day from 0 to 1 was an increase of 11 beetles. So if we went just a couple more hours, right, an extra 0.11 days, do you really think we'd get to 200 beetles? No. And we can also kind of see that mathematically too. So I'm going to kind of zoom down here. But if I had done 1.11 and plugged that in, I would never bother to actually do this math. But I can just kind of tell that like 1.11 to the 1.11 isn't going to get me 2, right? No, it's just not going to work because I would need to multiply 2 times 100 to get 200. There's no way. That's not how these numbers work. So I don't know what it actually is, but I know it's not that. And so now I'm left with D, which has got to be right, but the model predicts that the number of flower beetles grows by a factor of approximately 1.11 each day. And now we've also kind of done the mathematical like vocabulary piece of this question, right? What do these equations mean? So I highly recommend that you go through some of my videos, maybe search my channel for the word percentages. That would be good. and exponential models. Both of those kinds of questions are going to talk about what I call the open formula, okay? This is a way of organizing percentages on the SAT. And generally speaking, what it means is we take an original value, multiply it by a percentage, that's what the P stands for, E stands for equals, and we get a new value. This is some basic percentages. It's just put in like a clever way that helps us remember. But the benefit of the open formula is it's very versatile. If we're talking about percent increase, suddenly the formula changes into something more like this. O times 1 plus or minus, we can do decrease too, P equals N. So if we had something increasing by 20%, we can't just put 0.2 in for P and just call it a day. We need to show that it's a 20% increase. So the 1 plus 0.2 would tell us that. This is all stuff that's covered in much better detail in specific questions. Now, one of the places where this gets even more helpful is when we have an exponential equation, just like the one we have here. We can include this like way of thinking about percentages simply by adding a t or a variable of some kind to the percentage, because that's how exponential equations work. So let me copy this down. We have b of t equals 100, 1.11 to the t. So I'll put the 100 here, the 1.11 here to the t, and I'm going to just move the b of t over here, because that's basically what we've got, right? Look at the way that the question tells us what's going on. B models the number of flower beetles in a certain area where t represents the number of days after June 1st. So t is time. And which of the following is the best interpretation of the 1.11? Well, the b of t is the new number of beetles if we started with 100 beetles, right? The original number of beetles was 100. And we proved that when we did this right here, showing that when we plug in 0, which represents June 1st, we find that there are 100 beetles. So we can, this is why numbers are so helpful, is numbers explain things that, kind of get lost when we have a complicated equation, right? The 0 showed us something that, we could memorize, but if we didn't, we're not stuck. Well, the numbers can show us that as well. So that gets us to this piece then. What is the 1 plus or minus p doing in relation to the 1.11? Well, it's showing us here that if we subtracted that 1 out, we would really have had 1 plus 0.11. That is a representation of what's happening, how this population of beetles is growing. So it's an increase of 11%. And I know that doesn't appear anywhere in the question or the choices, but it's important to know. This is something that could come up on another question, is understanding where that number in those parentheses comes from. It's either representing an increase or a decrease from 100%. And so if that number is greater than 1, that means we're increasing by whatever the extra little decimal piece is. If it's less than 1, we've got a little bit of a harder thing to do, but it's going to be 1 minus p in that case, so you can do some subtraction to figure out what was the difference, how much of a decrease in percentage there is. But regardless, this word factor in choice D is doing a lot of good work. It's just another way of referring to this component of an exponential equation. It's a factor. It's how much we're multiplying by to increase the amount. It's not a slope. It's not a slope because it's not constant, right? We may have 111 beetles today, but it's not another 11 beetles tomorrow or another 11 the day after that. That number of beetles is going to continue to increase. So it's 11, and then let's say it's 14, and then 22. Like, that's going to increase as well. And if we had a calculator, we could prove that, but we don't need it if we understand how these equations are built. So I think the main point that you should take away from this is that when you are confused about how an equation functions, because you don't feel confident in what you've memorized about those types of equations, you have to be clever. You have to be strategic. You have to try to see, well, if I don't understand the abstract logic of a question, maybe numbers will show me what I'm failing to grasp, right? The numbers don't lie. And it doesn't take a lot to calculate things with zeros and ones. So be clever. Don't let a question like this stump you on the test. You can get these points if you are resourceful and strategic.